Okay, now our step 6 there says some atoms can be an exception to the octet rule. So let's look at some here. Boron is going to be an exception to the octet rule. Boron has 3 valence electrons. Hydrogen has 1, but we've got 3 hydrogens, so we've got 6 electrons to work with. So, bond everything with single bonds. We've used 6 electrons, we've used them all up. Boron's good. Now, carbon, nitrogen, oxygen, fluorine. These guys, the second row, will always follow the octet rule. But once we get down to row 3, period 3, and beyond, we can exceed the octet rule because there's an empty d orbital. We always satisfy the octet first, and then exceed it only if we need to. And we usually see exceeding the octet rule on the central atom. So let's look at this. Chlorine, 7 electrons. Fluorine, 7 electrons, but we've got 5 of them. So overall we have 6 things that have 7 electrons. We've got 42 electrons to work with. So we put chlorine in the middle, and then we're going to bond all 5 of those 4 fluorines to chlorine with single bonds. So 2, 4, 6, 8, 10. We've got 32 electrons left. So fluorine has to have an octet rule, so 2, 4, 6, 12, 18, 24, 26, 28, 30. We have 2 electrons left. And notice in these structures, lone pairs go away from where you put bonds. Okay, we have 2 electrons left, so where do they go? On the central atom. So fluorine has an octet rule, but chlorine has 1, 2, 3, 4, 5, 6 sets of electrons around it. So it's an exception to the octet rule.